Today we're starting chapter 8 and we're going to be doing some work with matrices. We did do some matrix work last year, but we're going to kind of expand upon those skills from last year. So first thing we're going to discuss is using matrices to solve systems of equations. There's going to be 3 different types of operations you can do. So this is the notation. It's important that at all times you're writing down a list of your notation. So I know what you're doing. So this first one right here means I'm switching the rows. So you are switching everything about it. So that means I'm taking everything in row 1 and I'm switching all the values in row 2. Number 2, this notation means it's a scalar essentially, so I'm multiplying everything in row 3 by 5. So this is the notation you want to do if you're multiplying something. We don't necessarily say dividing, but instead I would say I'm multiplying by a fraction. So if I needed to cut everything in half, I would multiply by a half. And number 3 is probably the trickiest one. This means I'm multiplying every number in row 1 by 2, and I'm adding it to row 3. So row 3 values are really the only ones that change. So these are the only values that change. So although you're going to multiply row 1 by 2, you're not physically changing that row itself. You're just using those values to add on to row 3. So we're going to do some practice of this. So here we have a 3 by 4 matrix. This line kind of represents your equal sign. So this top line technically means 3x plus 18y minus 12z equals 21. So here's our 3 rows, so row 1, 2, and 3. So here if I wanted you to switch the first 2 rows, it would become 1, 2, negative 3, 5, 3, 18, negative 12, 21, and then negative 2, negative 3, 4, and a negative 6. So notice nothing about that. I just switch row 1 and 2, and that is it. So going back to the original matrix, not the one that we did in letter A, this says I want to multiply everything in row 1 by a third. So essentially that means I want to divide by 3. So my top row will become 1, 6, negative 4, and a 7. And then 1, 2, negative 3, 5, negative 2, negative 3, 4, and a negative 6. So notice the rest of the rows remain untouched. For letter C, same thing. The only row that is changing is row 3. So I'm going to go ahead and take a moment. I'm going to write the first 2 rows because nothing's happening to them. So what is changing is row 3. So how we do this is we're going to take our values in row 2, and I'm going to multiply them by 2. So I'll just write down like the first step just to kind of show you, and then the rest we'll just kind of do in our head. So for that first value of 1, I would do 2 times 1, because that's in row 2, plus my original row 3 value of a negative 2. So 2 plus negative 2 would end up giving me a 0, so that's what I put in the first spot. So for the next one, I'm doing 2 and then times 2, because that's from row 2, plus a negative 3, because that's from the row 3 value. So I get 4 minus 3 is 1. Then I have 2 times negative 3. And I'm adding that to 4. So negative 6 plus 4 is negative 2. And lastly, we're doing 2 times negative 3 plus a negative 6. So negative 6 plus a negative 6 is a negative 12. And again, as you feel more comfortable with this step right here can be done in your head. You don't need to write that part out. So those are some of the operations we're going to be using today. We're going to go through and work one problem out, and then that'll be it for our video. So when you're solving with your matrix, the goal is that you want your final matrix to look like this. So I want 1s on the diagonal, and what we don't really care about is the values that are over here. So, and the way we would interpret this Actually, you know what? You don't need zeros up here. These could be anything. It's the zeros that are below that are important. So the way we would work this is that I would now know that z equals whatever number is in that bottom spot, and then I could use that to find my y value, and then I could use that to find the x value, and I'll show you how to do that. So here's our first problem. We have a system of equations. So the first thing that we would want to do is set this up in matrix form. So I have 3, 1, 2, 31, 1, 1, 2, 19, and 1, 3, 2, 25. And again, it's very important you take your time on these, because if you make one mathematical mistake, the whole thing will be wrong. And it's important that you write your steps down, because if you made a mistake and I need to go back and check it, I have to be able to follow your work. So the first thing that we need is we need a 1 in this spot right here where the 3 is. So I have two options. I could switch rows, or I could multiply this top row by a third. However, if I multiply by a third, the rest of the numbers in this row are not that nice, and then I'll have fractions and decimals, so I don't really want to do that. So instead, I'm going to switch, I'm going to choose to switch row 1 and 3. Now, actually we could switch row 1 and 2. So let's just switch row 1 and 2. You could choose to do 1 and 3. Both would work. So if I switch row 1 and 2, I'll have 1, 1, 2, 19, 3, 1, 2, 31, and 1, 3, 2, 25. And the strategy for these is that you want to get the 1 in this spot here, and then the goal is you want to get zeros directly below it. So you always want to work down instead of working, getting your 1s. So now that I have this 1 locked in place, I'm not going to change row 1. And the goal is I want to get zeros below it. So I'm going to do two operations at once here. To get a 0 in row 2 below this top 1, I'm going to multiply row 1 by -3 and add it to row 2. And then again, I need a 0 right there. So I'm going to multiply row 1 by a negative and add it to row 3. So I'm going to be doing two operations at once here because they are both exclusively separate from one another. So the only row that's not changing is my top row. So I have 1, 1, 2, 19. Alright, so I'm going to do this top one first. So I'm multiplying everything in row 1 by -3 and adding it to row 2. So -3 times 1 is -3 plus 3 is 0. -3 times 1 is -3 plus 1 is -2. -3 times 2 is -6. -6 plus 2 is -4. -3 times 19 is -57. 57 plus 31 is -26. Okay. Now I'm going to go through and I'm multiplying row 1 by negative and adding it to row 3. So as you can see that these two operations are not dependent on one another. So -1 plus 1 is 0. -1 plus 3 is 2. -2 plus 2 is 0. And then -19 plus 25 is 6. So we're off to a good start. Again, I get the 1 up here, so it's important that I get the 1, and then you work your way down. Now the next thing I want to address is this 2. I need to make that 2 become a 1. So the next thing I'm going to do is multiply row 2 by -1/2. So row 1 is done. I don't need to touch that. Row 2 is now going to become 0, 1, 2, and a 13. So, and I will have to switch the screen, so let me do that real quick. So now I have my 1, 0, 0, I got my second 1, so the next thing I want to do is change this 2 right here in the bottom row to be a 0. So again, you always want to use that 1 that we've locked in place above it. So I'm going to multiply row 2 by a -2 and add it to row 3. So I have 1, 1, 2, 19, 0, 1, 2, and a 13. So now negative 2 times 0 is 0 plus 0 is 0. Negative 2 times 1 is negative 2. Negative 2 plus 2 is 0. Negative 2 times 2 is negative 4. Negative 4 plus 0 is negative 4. And then negative 2 times 13 is negative 26. Negative 26 plus 6 is negative 20. And then the last thing that we would want is a 0 in this last spot, or a 1, sorry. So my last calculation is that I would be multiplying that bottom row by a negative 1/4. So I have 1, 1, 2, 19, 0, 1, 2, 13, and a 0, 0, 1, 5. So at this point we are almost done. We have one last final step. The whole purpose of doing this is to solve and find what x, y, and z are equal to. So this bottom line I can interpret and say that I know z equals 5. So I have one answer. From the middle row, I know that I have 1y plus 2z equals 13. And that's coming from these coefficients. And I now know that z is 5, so I can say this is y plus 10 equals 13. Subtract 10 over, I now know that y is equal to 3. Then I move to the top row. So now I'm looking at this row. So I have x plus y plus 2z equals 19. So I have x plus 3 plus 10 equals 19. So x plus 13 equals 19. When I subtract that 13 over, I get x equals 6. So at this point we are now done. We've solved. So my answer, the solution is 6, 3, 5. Okay? So we will definitely do a lot of practice on this tomorrow.